Bismillahirrahmanirrahim. My name is Husnain and my group members are Adeel and Ashir, and we are from Industrial Engineering Department batch 25. So today our topic of presentation is bisection method and Regula Falsi method. So here we will discuss what is bisection method, what is Regula Falsi method, what is advantages and disadvantages of both method, and at last we will discuss its application in industrial engineering. So without wasting any time, let's start with what is bisection method. In bisection method, we start with an interval and half its width until the interval is sufficiently small. So as long as the initial guesses, the function will have one positive value and one negative value. I will further explain it to you with the help of figure. So now if you focus on the figure, we have FA1 and FB1. So we know that our root lies somewhere in between FA1 and FB1, because FA1 is positive value and FB1 is negative value. So now what we do, we will perform iterations, iteration 1, 2, 3, 4 and so on. What we are doing, we are getting close to this red dot, which is our target, you can say our objective, our exact roots. So let's do an example. So for example, I have picked a question from our assignment, which is function value x plus x to the power x is equal to 100. So as you have noticed, when we implement 0 in this function, we get minus 100. When we implement 3 in this function, we get minus 70. When we implement 4 in this function, we get 160. As I have told you previous, 1 will be the positive value and 1 will be the negative value. So we came to know that our root lies somewhere in between 3 to 4. Now what we will do, we will bisect it. That's why it is called bisection method. In first iteration, we will do 3 plus 4 by 2, we will get 3.5. When we implement 3.5 in the function, we get negative value minus 16.2. So now we can say our root lies somewhere in between 3.5 to 4, not between 3 to 4. In second iteration, we will again bisect it. 3.5 plus 4 by 2, we will get 3.75. When we implement 3.75 in the function, we got positive value. So now we can say our root lies somewhere in between 3.5 to 3.75. Again we will bisect it. We got 3.625. We will implement the value. We got a positive value. So our root, in third iteration, our root lies somewhere in between 3.5 to 3.625. As you have noticed, we are getting close to our exact root. In the fourth iteration, again 3.5 plus 3.62 by 2, we got 3.562. Implement the value in function, we got negative value minus 415. So negative value indicates that our root lies between 3.562 to 3.625. Again we will bisect it. We got 3.593. again put the value in the function, we got a positive value which is 2.62. so our root lies in between 3.562 to 3.593. so now came to the sixth iteration. We have 3.562 plus 3.593 by 2, we got 3.577. so when we implement this value in the function, we got a negative value which is 0.9375. so now we can say our root lies somewhere in between 3.577 to 3.593. so again we will bisect it. We got 3.585. you have noticed how much closer values are coming, how much same values are coming. 3.585, implement it in the function, we will get a positive value 0.82. so now our new roots lie somewhere in between 3.577 to 3.585. so eighth and our last iteration is, again we will bisect it by 2. We got 3.589. when we implement it in our function, we got 1.71, which is positive value. The positive value indicates that our root lies somewhere in between 3.585 to 3.589 advantages and disadvantages of bisection method. So one of the advantages of bisection method, it is very simple method, very simple to implement. As you have said that we have simply divided by 2. So when we look at its disadvantages, it is time consuming, it is very time consuming. And one more its disadvantages is that we are bisecting it by 2, so it is possible that we will ignore the exact root value. So now I would like to invite Adeel Ghafoor to further explain Regula Falsi method. Adeel Ghafoor, now it's over to you.
Thank you. As my group member Husnain told you what are the derivations, calculations and advantages of the bisection method. Now, I will tell you what is the history, derivation, graphical representations and examples of Regula Falsi or false position theorem. Let's start without any delay. First, I will discuss about the history of Regula Falsi or false position theorem. In mathematics, the Regula Falsi or false position method is a very old, between the 9th and 10th centuries. The Egyptian mathematics Abu Kamil wrote a note laws treatise on the use of double false position, known as. It was used for centuries to solve practical problems such as commercial and mathematical. Now, what is the Regula Falsi or false position theorem? The Regula Falsi or false position theorem is a numerical method for estimating the roots of a polynomial f of x. A value x replaces the midpoint in the bisection method and serves as new approximation of a root of f of x. The objective is to make conversion faster than bisection method. Now, here graphical representations of Regula Falsi or false position theorem. In this graph, I take a comma f of a and for y b comma f of b. Then use the line equation of line for this representation. Derivation of Regula Falsi or false position theorem. In this theorem or method, we will use equation of line m equal to f of b minus f of a over b minus a, using points that are discussed earlier in the graphical representation, a comma f of a and b comma f of b. M equal to f of b minus f of a over b minus a, this is our first equation, and using c comma 0 and b comma f of b, then put it in the equation of line, we achieved 0 negative f of b over c minus b. This is our equation 2. Then equate it in both equations. We finally achieved c equal to b minus f of b into b minus a over f of b minus f of a, that is equal to a f of a minus b f of a over f of b minus f of a. Here, practice question or example of Regula Falsi method. In this question, first we will find out the intervals. For finding the interval, we will put the values of different integers in the function, like 1, 2, 3, 4 up to so on. We will put the values in the x sin x, then achieve the interval between positive and negative. After achieving interval, for this example or like this example, over interval is lies between 88 and 89, crossing the values negative 46.88, 26.55, that is between the positive and negative values. Now, then we will put these values in the Regula Falsi or false position theorem that is discussed earlier. After putting the value, we will find the answer. Then we will put this answer in the function. Then same iterative method we repeat till to achieving the say two consecutive same iterations or according to questionnaire restrictions. Remember that answer we will achieve from the formula, then we will put in the function. After putting the function, if across answer is positive, then change the value across the negative positive integer. If achieving answer is negative, then we will change the negative integer acrossing the value. This is all iteration of these questions. Now here the second question, x cube plus x negative 1000. Similarly, in this question, we achieved interval 9 and 10 by putting the different integers in the function. After this, we will put these values in the final formula, that is our Regula Falsi or false position theorem, a comma f of b minus b comma minus b into f of a over f of b minus f of a. Then similarly, we iterate this question till to achieving two same iterations. In this question, similarly, if we achieved negative value, then change the value across the negative value. If we achieve positive value, then we change the integer across the positive value. Means that in this case, in the iteration 1, sorry, we achieved negative 71.95. That is answer. If we, that is answer of our function, then we change 9.72 in this iteration. Similarly, we repeat this operation or method. This is iterative iteration of this question. Now I will discuss about the some guidelines and some stopping criteria about the Regula Falsi or false position theorem. We will iterate it till to achieving two consecutive same iterations. Sometimes questioner will give you conditions, solve it till to two decimal places, 3, 4, up to so on. Most probably initial guess is given. Remember that when trigonometric ratios are involved in the function, now we will use the radian measure for calculation, for calculator. Now I will discuss about the advantages and some disadvantages of the Regula Falsi or false position theorem. Estimate of maximum error, convergence guarantee. It is fast method than bisection method. It does not require the derivative calculation. This method has first order rate of convergence. It is linearly convergent. It always converges. Now some disadvantages of Regula Falsi or false position theorem. It is slow as compared to other method like secant and Newton-Raphson. Require two good initial estimates which define as interval around roots. It is used trial and hit error method. It is used to calculate only single unknown in the equation. Now I will invite my third group member Muhammad Ashir to present application of Regula Falsi and bisection method.
Thank you, Adeel. Now from here I carry on the presentation as my group member Mr. Adeel and Husnain gives you a detailed brief on bisection and Regula Falsi. I hope you all understand it well. Now I will tell you the real life application of these. So in our list, the first application we have is of CAD. Now here it is important to know what is CAD. It stands for Computer Aided Design. It is basically the use of computer to aid in the creation, modification, analysis, or optimization of design. Different types of CAD software is used by architects, engineers, drafters, artists, and others to create precision drawing or technical illustration. Now, here the question arises, what it has to deal with bisection and Regula Falsi. The answer is when we have to draw a certain geometry on CAD which has some curve parameter, like to draw 3D model of a car. So here to represent curve geometry, different types of curves are used like Bezier curves, B-spline, etc. And they all have certain control points to control or manage the behavior of curve. the computation that is running behind to draw these is of different polynomials, and by changing any control point, how exactly the curve follows the instruction is done by finding of rules, example bisection and Regula Falsi. Now here we comes to our second example, that is of air pollutant produced by combustion. The Regula Falsi and bisection method is applied for prediction of trace quantities of air pollutant that is produced by combustion reaction. These are mainly found in industrial point sources. So for this we have to calculate the maximum theoretical efficiency which may be achieved in a combustion process. But it is difficult as the equation describing the equilibrium state are stiff. So to overcome it, we reduce the system to that of one equation and one unknown, in which we can apply Regula Falsi and bisection method, but in its modified form. The Regula Falsi and bisection method is modified through the introduction of an under-interpolation factor. By doing this, it accelerates the convergence rate. So in this way, we can find the quantity of air pollutants. Now, let's move on to the third application, that is of short detection in video content for digital video library. So, what is DVL? It stands for Digital Video Library. It is basically a network internet application allowing for storage, searching, browsing, retrieval, searching, and unicasting video sequences. Experiments show that by usage of bisection, it accelerates the process by 0.002 times faster as compared to the ordinary one that is of short density. Thus, browsing functionality can be significantly facilitated by a fast short detection process. It just becomes like a search engine where we can get only those information related to our type word. This DVL is also developed for medical professionals to get their required topic in a video fast. Now, let's move on to the fourth topic, that is of thermocouples. So, what is thermocouple? It is an electrical device that is used for measuring temperature. It consists of two wire legs made from different metal creating a junction. This junction is where the temperature is measured. When the junction experiences a change in temperature, a voltage is created. Then this voltage is interpreted using polynomial equation by thermocouple, in which chance of error is reduced by using bisection and Regula Falsi. That it gives us reading of temperature nearer to the accurate. So here I conclude the presentation. I hope you all understand it well. If you have any question, kindly feel free to ask. Okay, no question. Thank you.